Good morning, everyone. So today we're going to talk about scaling OpenStack to support large-scale compute. So this is Kathirvel from AT&T, lead system architect.
I'm Chip Kelley. I'm an engineering manager at Ericsson.
In AT&T, we have a large-scale cloud deployment, and today I'm going to share about what we have learned in terms of supporting a large-scale OpenStack within our cloud. So I'm going to talk about a couple of points like what do we really mean by scaling and how big we want to scale the OpenStack within a particular site or a data center. So typically in a data center, there's about 3,000 plus servers we need to support within the data center, right? Some data center may actually go about 10,000 servers in a particular location. So that's a typical telco enterprise use cases. So the question is how many servers or how many compute we will put it within the OpenStack single instance within a data center to support this particular scale. So there's a lot of discussion about, can we put all the 3,000 servers in a single OpenStack instance, or whether we put it in multiple instances. So one of the study what we have conducted is when we put all the servers into a single OpenStack instance, for example, in a region, then if that region has an impact in terms of the availability, then there's an impact to the application which is running on that application. So what we call is that as a blast radius. So if there is an impact, then the VMs within that particular OpenStack instance are going to have impact, and that's going to create less availability for the VMs. So we need to be cautious of how many compute maximum we can put it within that OpenStack region. So that's what we call as a sweet spot. So the sweet spot really varies between between the data center and how the VMs are deployed with respect to that particular data center. But typically in a telco world or in an enterprise world, the number of servers which can be deployed with respect to the region, it's really dependent upon the OpenStack software maturity and what the shared network and hardware which is actually shared with respect to that particular data center. So the fact of what we have learned is that when you try to push your OpenStack number of compute with respect to that region in that location, we identified that if you're in the ballpark number from 500 to 1,000, that is actually a good number to keep stable OpenStack and supporting the VNFs and VMs within that particular region. So what we have identified is when you have a 3,000 server, you don't want to put all 3,000 servers in a single instance of OpenStack, but instead you put it in multiple instances of OpenStack within that data center, which gives you more availability. So there are a few things we have tried in our cloud, and we have learned, and we want to share that experience with you guys. The number one is actually about do we really have Keystone, Horizon, and in a central layer, meaning that you deploy in a central location, then you have multiple regions in the sites, like the way we were seeing on the previous slide. So the one thing we have learned is that when we deploy the Horizon and Keystone in the central location, so the issue what we have faced is that the replication between the Keystone and Horizon, the database into multiple data center. And when there is an impact to that common elements, then there is an impact to all the regions which is actually on the site, which takes down the multiple sites if you have an impact to the Keystone, because Keystone being the critical component in the role of the OpenStack. So what we have learned is keeping all the components contained within that particular region helps you actually to increase your availability than actually keeping some of the central component. It's really a bargain what is the availability you're really trying to achieve with respect to your OpenStack cloud. So what we have learned from a telco and enterprise workload is more you contained with respect to that region, then you have a standalone OpenStack instance, but you do need an Uber orchestration to manage those many regions or the sites, but do not centralize the Keystone and the Horizon. Then there is another context is do we use cells or no cells with respect to supporting that 1,000 compute, what we saw in the previous slide. So the cells are actually getting more matured in the Newton release, but if the deployments are actually pre-Newton, then you cannot really use the cells because it's not to a production readiness in order to support that particular scale. So I think from a Newton release, it's definitely cells will help actually in scaling that OpenStack instance in order to support that 1,000 compute with respect to that location. So this is a study we have done. So we have conducted actually a lot of analysis in terms of testing the scalability of OpenStack in a multiple factor. So this chart actually explains what do we really see the challenges with respect to the components with respect to OpenStack in terms of the scaling. So for example, Ceilometer, when we try to have like 1,000 compute in a single region and you enable the Ceilometer and you have like about 20,000 VMs, then you can see that Ceilometer database, like really getting a long hit there. So it doesn't perform the way you really want it to be. And RabbitMQ is another challenge when you try to scale to 1,000 compute. Then another thing is Nova Scheduler. Especially in the Nova Scheduler, when you put all the compute in a single availability zone and you try to support, the scheduling of that 1,000 compute using a single Nova Scheduler, then, you have a problem. The right-hand side of this picture, it shows that, when I have a Nova Scheduler, and if I only run a single thread of the scheduling process, then pretty much, you can see that, I'm really getting hit when I have 100+ users and trying to create, the number of VMs, it really less than actually having that multiple scheduler threads running on to actually support multiple instances I can create. So this will get actually more improved with respect to introduction of the cells, but pre-cells era, we do have a problem in terms of hitting the number of compute, how much we can scale, and how many VMs we can concurrently create using this particular instance. So the other factor is that MySQL. So MySQL is also having a problem, when you have a MySQL and when you try to actually have 1,000 computes and trying to create multiple VMs at the same time, especially when you have a provider setup. So you get a lot of hit with respect to the MySQL. And then the neutron scalability. So these are the 5 primary components, usually you get a hit when you try to scale to even to 500+ compute within a particular data center. So there are tricks that you can do actually to overcome some of those issues. For example, you can have RabbitMQ set up a multi-cluster mode, and you can have a multiple Nova scheduler running onto it. And Ceilometer, you still have a performance issue. So you can do some of the tuning with respect to these systems, and you can change a little bit of the architecture. There are a lot of people talked about in the sessions how they have tuned OpenStack and especially these components to achieve the 1,000 compute stuff. But what we have really learned is that when you try to do all this tuning and all the stuff, the key issue is that you still need to achieve that availability number. For example, you need to achieve 4 nines or 5 nines availability. Then tuning all these things it doesn't really help much with respect to really achieving the availability with respect to that scale. So one of the things we need to be very cautious and we have to be mindful of is that when the new concepts are actually inserted into every project of OpenStack, we need to be mindful that scaling is one of the requirements that is really need to be met. So instead of tuning and bolt on at the later stage, we need to have the concept of the scaling is really in the design of each component, so that we are really taking care of the scaling metrics into the design itself.
Thank you, Ken. So for those of you that attended the OpenStack Summit last in Austin, there were a lot of presentations with AT&T and Ericsson talking about 5 nines and carrier grade, particularly in the telco and large enterprise environment. And a lot of the speakers really talked about, we need you guys as a community to help us solve some of those issues. And very much in line with that, because there was a great response from that summit, we need sort of the same thing here in terms of scalability for you guys to really help us solve some of that problem. And like Ken just said on the last slide, not only bake it in, but bake it in so that it's production ready. For those that attended the keynote sessions this morning, the first speaker talking about the banking big data, one of the things they concluded with is we need these features to be production ready to scale and be carrier grade. So some of the things we need to work on is, on the Nova side, publish scale test results with every release and make sure that the scalability is built into it. We really need a plug-in mechanism with Nova to allow third-party schedulers. That's an area that tends to get bottlenecked when you scale to large enterprises. We'd like to also kind of see some caching of the databases and reduce sort of the database polling to allow third-party schedulers in there as well. For Ceilometer, to improve its scaling, we need to use alternative bus and databases as well in there. Right now, Mongo sometimes can be really runs pretty hot, and so it'd be nice to kind of use some other third-party solutions in there to help with that. RabbitMQ, just like Cannon has said, a lot of what people are doing on that is sort of trying to deploy a fix, but when you get larger and larger, you really need a solution that can really scale up to 1,000 nodes. Since it's the messaging workhorse of deployments, larger clouds are going to make higher demands in terms of message brokering and that sort of thing in there. And MySQL, again, we would like to load balance, read queries among all the nodes in the cluster to distribute out the load and fully support active-active at a large level. And so, any questions? We got about 1 minute left.
Yeah, so the sweet spot is what we identified as like the scale where you can actually really achieve the availability of the OpenStack itself, right? So you can push to 3,000 server or 4,000 server, but if it is going to be very shaky, then it is very hard to really run as a production environment. So what we have identified is like, if you are in the range of 500 to 1,000, actually that gives you more scaling, but you still need to do all these fixes to really achieve that one in order to run in a production ready state. All right.
All right.
Thank you very much.